and white. Today I'm going to show you the steps to take to properly install a membrane switch. In this case, we will be working with a custom aluminum door panel assembly.
As you can see here, the aluminum door assembly that the membrane switch is going to be applied to is laid into the fixture. One of the key aspects of this fixture is the center portion that's been built up to support the LCD display window area when we apply the membrane switch. So what we're going to do here is check the LEDs with a custom designed power element. The LEDs are all lit, and what we're doing is pressing gently at each of the areas to assure that there's not any broken or intermittent contacts. By pressing on the areas, if there was an intermittent contact, the LED should flicker or go completely out. As you can see, that's not happening. These LEDs are functioning 100% properly. So you'll notice throughout this video that the person doing the assembly is grounded for ESD. It's that blue wrist strap she's wearing on her left arm. That's critical to assure that the LEDs are not subjected to any unnecessary static charge. First step of the assembly process is to remove the release liner that covers the pressure sensitive adhesive on the back of the entire assembly. One of the difficult parts of this assembly is the fact that there are 3 tails, one for the LED circuit, one for the switch circuit, and one for the shielding layer that have to be fed through the tail slots in this aluminum door. That's why we've designed the fixture so that you can slide it back and forth on the table even though it is securely supporting the door itself. This switch is aligned using the left or front edge, and then what we're doing here is rolling out the air starting from the bottom working towards the top. You'll see that the assembler is holding the corner of the switch up in the air. That allows the air to escape as we work it towards the top of the assembly with the soft rubber squeegee. The durometer of the squeegee is very important in an application like this because you don't want to harm the LEDs as the squeegee goes over top of them. So even though it's difficult to see in the video, that rubber roller is soft enough to not damage the LEDs or the resistors. What we're doing now is installing the tail filler pieces. If we didn't put these tiny pieces of mylar and adhesive into the assembly, once the overlay goes on, there would be a dip or an air pocket where the tail goes away from the membrane switch through the panel. So far so good. The next step is to apply the graphic overlay. We don't always do our assemblies in this manner. Many times the graphic overlays are already on the membrane switch, but in this case it was extremely difficult to do them as one single unit because of the 3 tails that are going through the door assembly. It's much easier to assemble this one in 2 pieces, 2 parts, like you're seeing here. Once the release liner on the mounting adhesive is removed, the assembler aligns the edge of the overlay with the edge of the membrane switch. You are able to quickly pull it up and replace it like is being demonstrated here, and then again with the soft rubber roller from the bottom to the top, holding the corner up so that there's a place for the air to escape at the very end. Right there, the roller going over that LCD display is why it's critical to have that support in there that we built into the fixture. If we didn't, the window of the overlay would flex through the hole in the metal subpanel, and it would put stress on the 2 LEDs you see right there to the right of the display. After final assembly of the graphic overlay, we want to test those LEDs one more time to make sure that we didn't have any static discharge, any faulty LEDs as a result. of the assembly process itself. And you'll see one more time the assemblers going through each of the LEDs and applying slight pressure to assure that we don't have any intermittent contacts of the LEDs or their corresponding resistors. And then what's happening here is the assembly person is going through each of the buttons, pressing the metal domes and assuring proper tactile feedback, assuring that we haven't inverted the metal domes or flattened them anyway, and that we still have normal functionality as intended.